This is question number 8 of GATE 2021 Metallurgical Engineering. Which of the following is false for creep deformation? A. Minimum creep rate is obtained in primary stage, stage 1. B. Creep resistance decreases with decrease in grain size. C. Cobalt creep occur via grain boundary diffusion. D. Nabro-Herring creep occurs via lattice diffusion. So, in order to learn more about creep deformation, you can refer lecture number 5 of creep deformation of materials course by Dr. Srikant Gulapudi, IIT Bhubaneswar. So, before solving this problem, let us first understand the basics of creep. So, creep is basically the progressive deformation of a material at constant stress, and the creep curve, which is plotted between strain versus time at constant load and temperature. And to be precise, if it is plotted at constant load, we call it as an engineering creep curve. So if you see a creep curve, it will typically have of this nature. So basically it starts with initial rapid elongation with the magnitude E0, and then it will go stage by stage. So the first stage, which we call it as the primary creep or stage 1. So if you see the creep rate, which is nothing but the slope of the curve d upon dt, if you see the slope of this curve is decreasing. So the creep rate basically decreasing in stage 1. Coming to the stage 2, which is also called secondary creep. So here the slope is almost constant. So the creep rate won't be changing. It will be same throughout this stage. So this stage basically arises when there is a balance between strain hardening and recovery, which will be taking place simultaneously. Coming to the last stage, which is stage 3 or tertiary creep. So here the creep rate is increasing as you increase the time, and finally the fracture will take place. So this is all about creep curve, and the remaining 3 options for this problem is basically related to the creep mechanism. So one of the important mechanism of creep is grain boundary sliding. So grain boundary sliding is nothing but it involves the slidings of grains passed to each other. And other mechanism, which is diffusion creep. So basically this diffusion creep is of 2 types. First one is grain boundary diffusion and second one is lattice diffusion. So if diffusion occur through grain boundary, we call it as a grain boundary diffusion, and if it is occurring through the lattice, so we call it a lattice diffusion. So other name of these two are basically cobalt creep and Nabro-Herring creep. Talking about the temperature, this lattice diffusion occurs slightly higher temperature than this grain boundary diffusion, and for a comparison you can see the temperature at which these two diffusion creep takes place. And if you see the stress sigma upon G value for both this creep, it will be less than 10 to the power minus 4. Now coming back to the options, so if you see the option A, the minimum creep rate is obtained in primary stage or stage 1, which is a false statement because the minimum creep rate will be obtained in stage 2, which will be basically secondary stage of creep. Option B is creep resistance decreases with decrease in grain size, which is a true option because as you decrease the grain size, the number of grain boundary area will be increasing, which will lead to aid the creep by grain boundary sliding, and hence the creep resistance of the material will be decreasing. Option C is cobalt creep occurs via grain boundary diffusion, which is absolutely right, and Nabro herring creep occurs via lattice diffusion, which is also correct. So the false statement for this question is option A. So this is the right answer, option A. Thank you.